All right, this is Math 65, Section 6.4. We're going to be looking at special factoring forms. So first we're going to talk about identifying square and cube roots. All right, a square root is a number. A number is a square root if the square of the first number equals the second number. So, what are the square roots of the following numbers? 81. Well, since 81 is 9 squared, 9 is its square root. 36 is 6 squared, so its square root is 6. For 25, 5 squared is 25, so 5 is the square root. 100 is 10 squared. That does not look like a 10, like an E. That looks like an E and not a squared. 10 squared, so 10 is the square root. 64 is 8 squared, so 8 is the square root. Nine, on the other hand, is 3 squared, so 3 is its square root. 4 is 2 squared, so 2 is the square root. Okay, not 2 to the 4. Sorry about that. 2 squared. 1 is also 1 squared, which makes 1 its own square root. That's why when proving things, we try not to use 1 because it is a very unique property. 2 also has a unique property. No other number, when multiplied by itself, is equal to the sum of it added to itself. All right, 16 is 4 squared, so 4 is its square root. 49 is 7 squared, so 7 is its square root. A number is a cubed root of a second number if the cube of the first number is equal to the second number. So 27 is 3 cubed, so its cube root is 3. 25 is 5 cubed, so 5 is its cube root. 8 is 2 cubed, so 2 is the cube root. 1 again is 1 cubed, so 1 is its own cube root. As I said, a very unique number. 64, on the other hand, is actually 4 cubed. It's 8 squared, but it is 4 cubed, so its cube root is 4. Now, what about a variable term? Find the square root of the coefficient, then find the square root of the variable. To find the square root of a variable, divide the exponent by 2. If looking for a cubed root, first find the cubed root of the coefficient, then divide the exponent by 3. Find the square root of the following. Well, the square root of 81 is 9, and half of 4 is 2, so it's 9x squared. Square root of 4 is 2. Half of 2 is 1. Half of 8 is 4. So we have 2xy to the 4th. Square root of 49 is 7. Half of 4 is 2. Half of 2 is 1, so we just have y. So it's 7x squared y. 36, the square root of 36 is 6. Half of 4 is 2. Half of 6 is 3. Half of 10 is 5. So the square root of 36, x to the 4th, y to the 6th, z to the 10th is 6x squared y cubed z to the 5. Now, for the cube roots, the cube root of 8 is 2. 3 divided by 3 is 1. 9 divided by 3 is 3. So we get 2ab cubed. Cube root of 125 is 5. 3 over 3 is 1, so we just have 5x. Cube root of 27 is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 12 divided by 3 is 4. All right, so this is just some practice on how to find squares and cube roots, because we have some very special factoring patterns that we use. One is the difference of squares. We saw this when we were doing multiplying binomials, where if I had conjugates, they had the same first term and the same last term, but one had a plus and one had a minus. These were conjugates. Sorry, there's something on my screen and there we go. Okay, I have a squared minus b squared. Remember, we were coming up with that. Well, now we're going the other way around. If we have a squared minus b squared, we turn it into the conjugates of the square roots. So x squared minus 144 would become x minus 12. 12 is the square root of 144. And x plus 12. X squared minus 169. 169, the square root of 169 is 13. So I have x minus 13, x plus 13. All right. Now, square root of 64 is 8. And the square root of 9 is 3. So we end up with 8x minus 3y and 8x plus 3y. For D here, we have the square root of 49 is 7. X minus the square root of 4 is 2y. And that's going to be 7x plus 2y. Okay. So now we move on to our second page. Oh, we have some more difference of squares to get through. All right, so I have 3x minus 6y and 3x plus 6y. All right, on this one, they're being a little bit tricky. The square root of x to the fourth is going to be x squared. So we have x squared plus and x squared minus. The square root of 256 is 16, I believe. But you know what? Just so that I'm sure I'm correct, I'm going to put that in my calculator real quick. And I can just check it by doing 16 times 16. I don't have to do anything funny or fancy. And yes, I get 256. So, 16 and minus 16. All right, x squared plus 9. Whoops, whoa, hold the phone. It's a plus, it's not a minus. So this does not work. This actually is prime. Okay, whoa. The sum of two squares with no common factor other than 1 is a prime polynomial. That's what we just did. All right, factoring perfect square trinomials. All right, so this is remembering our special pattern. The thing we've got to watch out for is this 2ab. We're looking for the square root of the a and the square root of the b, and looking to see if my middle term is twice their product. Okay? That's what I'm looking for. Now notice, when this is a plus, this is a plus. But when it's a minus, it's a minus. Other than that, the pattern's exactly the same. Okay? All right. The next factoring strategy reverses what we just talked about, that pattern. So, we're going to look and see the square root of 4 and x are x and 2. 2x times 2 is 4x. Yes, we have a factoring pattern here. So this becomes x2 squared. Remember that whatever this symbol is the symbol I'm going to put right there. So this is a minus, so I'm going to make it a minus. So my factoring pattern would give me x minus 2 squared. Okay, so this is a little bit easier. All right, so here, the square root of x is x. The square root of 25 is 5. X times 5 is 5x, times 2 would be 10x. So yes, this does fit my pattern. So I have x 5 squared. And again, remember that this symbol is the symbol that goes right here. In this case, that symbol is a minus. All right, on my next one, I have x and 8y. This gives me 8xy. Double that would be 16. Yes, I've got the pattern. So it's going to be x, 8y. Now, what I'm missing is my sign. So remember, plus goes right here. So I get a plus. All right. D, I have x and I have 4y. Uh-oh. 4 times 2 is 8, not 9. So this one would not factor as a factor difference of squares. All right. Sum of 2 cubes, a cubed plus b cubed. Now, I want you to look at both of these two patterns. Notice they're exactly the same pattern. The only difference is that when this is a plus, this is a minus. When this is a minus, this is a plus. These two follow the first pattern. Okay, so what we've got here is plus, plus, flip it. Minus, minus, flip it. Okay? That's how this pattern works. Other than that, the pattern's the exact same. Okay, so let's look at this. X cubed. So the cube root of x cubed is x. The cube root of 125 is 5. So I'm going to have the pattern. Okay, remember, it's x, and then it's whatever this symbol is, stays the same. So it's going to be x plus 5. Ugh, sorry. X plus 5. And then it's going to be x squared, right? A squared. Flip the symbol, minus a times b. Well, a is x and b is 5, so this is just 5x. Plus b squared, which is 5 squared, or 25. Okay, on this one, we're going to have z, because the cube root of z cubed is z. Cube root of 343 is, I think, 6. Nope. Seven times 7 is 343. So it's 7. All right. So same symbol, 7. Sorry, I was trying to write an X. Z squared. Flip the symbol, 7z plus 7 squared, which is 49. Okay, so that's my factoring pattern. Now we're going to do this with a difference of cubes. Z cubed gives me Z. 343 cubed is 7. 216 is 6, the cube root, just so you know. All right, so Z same symbol. So that's a minus 7. And then Z squared, flip the symbol, plus Z times 7, so 7Z, plus the last term squared, which is 49. All right, so our next one, we have Z in 6. Don't forget, we're going to flip that symbol on the second situation. Okay, so second set of parentheses. So we have Z minus 6, Z squared, flip the symbol, plus 6Z plus 6 squared is 36. All right, so we have 3x and y. So 3x minus y, and then 9x squared plus, this all multiplied is 3xy, plus y squared. And that would be factored. Okay, and I believe we are done. Yes, we are done with these. Have fun on your homework.